Alright, today's lesson is going to be covering lesson 3 of chapter 9, going over experimental probability. So our key idea with this lesson is the definition for experimental probability, and it is probability that is based on repeated trials of an experiment, and that is what experimental probability is. So it's the repeated trials of an experiment. So this one is going to be written as P with the event in parentheses equals, we've got a new different ratio that we're looking for. And this ratio is going to be the number of times the event occurs to the total number of trials. So the number of times the event occurs to the total number of trials. So we're going to be looking at a couple of examples, and you should be taking notes so that you have those for your test and help you with your homework. We'll go ahead and get started. So our first example is just kind of like a standardized test practice that you might see on a test, like they had the state test or something. So the question is 13 out of 20 emails in your inbox are junk emails. What is the experimental probability that your next email is junk? And so they give us the options of 35%, 45%, 55%, and 65%. So once again, we write this out as P, the event, equals number of times the event occurs over the total number of trials. And so we use numbers from our word problem. So P, junk, we've got 13 and 20. So 13 is the number of emails that are the junk, and 20 is the total number of emails. So we would have our ratio of 13 to 20. So that gets written 13 to 20. When you divide that, it gives you a 0.65 or 65%. And so that tells us that D, 65%, is the answer to this problem. All right, the next thing that we're going to be looking at is making a prediction using experimental probability. So this question is asking, it rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? So we do our experimental probability for March, and that is 2 out of 12. So 2 over 12, and when we reduce that, it gives us 1 over 6. So then to make our prediction, we take that 1 over 6, we multiply it by the number of days in April. There are 30 days in April, so 1/6 times 30. We put that 1 underneath the 30. 1 times 30 is 30. 6 times 1 is 6. 30 divided by 6 is 5. So we can make the prediction that there will be 5 rainy days in April if the trend from March continues. And that's how you make a prediction using experimental probability. So last, we're going to be looking at comparing experimental and theoretical probability. So we have a bar graph, and our bar graph is counting the number, is looking at rolling a number cube. So down at the bottom we have the numbers on a cube. On a number cube, you would have 1, 2, 3, 4, and 5, and 6. 1, 2, 3, 4, 5, and 6. And then on the side here, we've got times rolled. Okay? So our bar graph tells us that the number 1 was rolled 10 times, our 2 was rolled 4 times, 3, 8 times, the 4 was rolled 11 times, 5 was rolled 8 times, and the 6 was rolled 9 times. So we're going to use these numbers here in our bar graph to answer the question comparing theoretical and experimental probability. All right, so comparing experimental and theoretical probability. So the bar graph shows the results of rolling a number cube 50 times. So the number cube was rolled 50 times in total. What is the experimental probability of rolling an odd number, and how does it compare with the theoretical probability of rolling an odd number? So we look first at our experimental probability. So P, the event, equals the number of times the event occurs over the total of trials. So P odd, and if we look at our bar graph, and we want to look at 1, 3, and 5, because those are our odd numbers. So if we take 1, that's 10 times, plus the number for rolling 3 was 8, plus another 8. And that's going to give us 26 for our total times rolling an odd number. So we've got 26 over 50. 50 is our total times that the number cube was rolled. 26 is the odd number rolled. So when this gets reduced, it gets reduced down to 13 over 25. So then we're going to look at our theoretical probability. And so remember, with theoretical probability, that is the P event equals the number of favorable outcomes over the number of possible outcomes. So we look at our number cube graph, okay? The possible outcomes are going to be 6 because there are 6 numbers on the number cube. And the favorable outcomes, there are 3 favorable outcomes of rolling an odd number. So 3 odd numbers, 6 is the total of numbers. So when we reduce this ratio, we get 1/2, or 1 over 2. So the experimental probability is 13 over 25, which equals 0.52, which equals 52%. The theoretical probability is 1/2, which equals 0.5, which equals 50%. So our experimental is 52%, our theoretical is 50%, so our two probabilities are similar. All right, and that was a look at experimental probability. It is now time for you to do your on your own questions. Make sure you have your on your own questions completed so that we can go over the answers in class tomorrow. And then for the rest of the class period, we will be working on the assignment. If you have any questions, that is your chance that you can ask me questions on your homework while you are working on it. And I will see you in class tomorrow.